So we were discussing briefly with Shubham, the incredible ROSCON we had last week in India. I mean, I was
fantastic. Yeah.
indeed.
Still feels like a fever dream to be in Bangalore talking about ROS and Zenoh and all of this.
Yeah, it was just incredible. Okay, Yadu, the floor is yours. I'll let you introduce yourself and keep going. Thank you very much again for being here.
Thanks, Angelo. A very warm good morning, good afternoon, good evening to all our viewers here. I'm really excited to talk about RMW Zenoh as we wrap up the year 2024. And this is going to be a review as we close the year. So my name is Yadunund Vijay. I go by Yadu for short. I'm a senior software engineer at Intrinsic, formerly Open Robotics. And I'm a project management committee member for the ROS2 and OpenRMF projects. And I've also had the privilege to serve as the ROS boss and the release lead for the 9th release of ROS2, Iron or Winnie, which was transitioned to end of life just earlier this week. You can follow me on GitHub and LinkedIn via these two links. And so let's jump right in. So about a year ago, Angela and the ZettaScale team invited me and Franco over to Zoom 2023 to talk about what Open Robotics / Intrinsic has been working on. And something that we brought up was our hunt for an alternative middleware. So for the longest time, we've heard a lot of feedback from the ROS community, ROS2 specifically, and people are facing certain challenges with DDS. So we set out on this hunt to find an alternative middleware. We conducted this very systematic study of several different protocols, which we found to be suitable, that met certain requirements. And then from there, I'm sure everyone's heard of this a million times now, but just for completeness, I want to go over it really quickly. So we had this exhaustive criteria or this table, which we used to evaluate various different kinds of middlewares. And then we selected Zenoh to be the next middleware on top of which we will build support for ROS2. And of course, all of this is possible because ROS2 has a modular architecture and we can really swap out the middleware at runtime. And it was great to see that our results independently matched results from the survey we had also sent out. So users from the ROS community filled out a survey and suggested certain protocols for us to look at. So our results matched those results. So overall, I think the entire community and the core team were pretty aligned on what protocol to use to build the next middleware. So this was the exact slide that we presented a year ago. And back then, RMW Zenoh was in very nascent stages. We had set out this bold goal of having a source installable version of RMW Zenoh available for ROS2 Jazzy Jalisco, which was released earlier this year. And a year ago, the progress of RMW Zenoh was that we only had pub sub functioning and a little bit of graph introspection. A lot of the core functionalities like RPC calls via client service interactions, being able to support different QoSs, events especially, were all unsupported, right? And then since then, I'm really happy to share that first and foremost, we met the goal that we set out to achieve last year, which was to have a feature complete and source installable version of RMW Zenoh available with Jazzy. So this is Chris Lalancet, the ROS2 technical lead, presenting this at ROSCON in Denmark earlier this year. And we're really proud to announce that we have this feature complete RMW. And so what does that really mean? It means we have full support for pub sub client service as well as ROS2 actions, full support for graph introspection, along with all the different command line interfaces that are now supported with RMW Zenoh, different kinds of QoS quality of service levels that we also support. And most importantly, we've nearly gotten all the core tests to pass. And I'll talk a bit more about why this is important in a moment. For the sake of completeness, so this is what RMW Zenoh functions out of the box. So by default, the topology of Zenoh that we've adopted is one where discovery is brokered using a router. And once the different peers, which are ROS nodes, discover one another through gossip, all of the transport happens peer-to-peer, right? And we've selected to use TCP as the underlying transport mechanism for both discovery as well as payload transport. By default, discovery range is limited to local host only. So when you're running on a PC, by default, all of that information stays within that host. When we want to connect two or more robots or computers, which is typical in any multi-robot application, our recommendation with RMW Zenoh is to simply connect the two routers. Again, this is a flexibility that's offered by Zenoh itself. So instead of having every node discover every other node in the second PC, we simply have these two hosts discover each other through the router. And then in this case, transport is also brokered. So that's one distinction to keep in mind. And we're really happy to share some cool examples of RMW Zenoh in action, kind of highlighting everyday use cases, as well as some things that were very hard to do with DDS in the past. So here we have the usual Talker demo example. So this is running on the same host. So before you can start any node, you need to start the Zenoh router. If not, you'll be met with a few warnings like this. And once the router is started, the Talker node should kick off. And then you can start your listener to start receiving messages. And then the elephant in the room, of course, is this looks very similar to ROS1. What happens if the router crashes? And here you can see that we've terminated the router program, and we're still receiving messages on the listener side. Again, this is because the router only helps with discovery. And since the talker and listener have discovered one another, they can continue exchanging information over TCP transport. And anytime the router comes back on, things are as they were before. We also want to highlight that discovery is robust. So here's a stress test of sorts. We have two computers, one computer on the left and the right. So we start a router on the computer on the left, and then we're basically launching 10 nodes that each publish about 10 topics or 100 topics, I forget. So overall we have about 1,000 topics. And now on the second computer, we're simply updating the router there to say, hey, connect to a router on the first computer. And once that router starts up, we can then run our usual ROS introspection commands, like listing out all the topics. You can see that was almost instantaneous. And then if we look at timestamping this or benchmarking the results, we're able to get all of these values in less than a couple seconds, which is pretty impressive. And it's correct on the first try. You don't have to keep running ROS2 topic list. Next, and a really cool feature that's typically very hard to do with DDS-based middlewares is being able to send data over all these different hops, network hops, right? So here I have a robot in my house running nav2, and essentially Julien from Paris is able to connect to the same Zenoh session. This is possible because we have an intermediate router in the cloud. So there's a router here running on my Raspberry Pi at home on the TurtleBot, and then Julian's able to connect to my router essentially through this gateway router in the cloud. And once that's possible, he's able to localize the robot remotely and even send it a navigation goal. So this is typically something that's really hard to do with UDP and other DDS-based protocols, especially without a VPN in the loop. So the fact that Zenoh can do all of this out of the box is going to open up a lot of other capabilities with robotics, especially with multi-fleet robotics. Another cool feature is being able to downsample data or messages as and when needed. So here's a cool example of us publishing an image at 30 hertz. So this is on one of the computers. So you can see messages are being received at 30 hertz. And on the second computer, we're able to subscribe to the same information. So we're getting that image at roughly 30 hertz. But then we can go back to the first computer and then quickly modify something in the router config to say, hey, when you send this information out of this computer, send it out at a frequency of 3 hertz instead, right? So it's just a simple configuration change. We're able to start that router again. We don't have to kill or restart any other nodes. And then if we go back to the second PC, we can now see that we're receiving that data at the 3 hertz frequency that we had requested for. This is, again, going to enable a lot of cool robotics applications out of the box. I know a lot of companies out there are building dashboards, and oftentimes you want to stream data from your robots, but maybe not at the same at the same default frequency that other control algorithms are relying on. So this is a cool way to get data out at whatever rate that you need. All right, so all of that was presented at ROSCON. So a lot of you must be wondering what's new about it. Well, it's been a couple of months, but I'm really happy to share that we've made significant progress since ROSCON. First and foremost, RMW Zenoh is now jamming to Zenoh Firesong. So we've officially migrated RMW Zenoh to Zenoh 1.0. I think we're at a patch right now, 1.02, I believe. And then we're currently in the progress of migrating to Zenoh CPP to fix some other issues that we've seen. So this is fresh off the press, hot out of the oven. We're super happy to share this, and I'm sure the entire Zenoh and ROS community are really excited about this. Building on to that excitement, I'm also super happy to share that we've nearly gotten all the system tests to pass. There are a few tests that are still flaky or are failing at the moment. What's important to highlight is that we have several hundreds of tests in the ROS ecosystem from various different packages like RCL-CPP, RCL-Pi, but we've also have dedicated test suites where we test everything from communications, quality of service, transport, discovery, etc. So think of it as several hundred tests are out there, and we only have less than a dozen that are failing. So it's looking really good. And another exciting announcement since ROSCON is that now RMW Zenoh is fully supported on Windows. So Windows, as you might know, is a tier 1 supported platform for the ROS community. And we've been shipping ROS binaries, ROS precompiled binaries to Windows. And now Windows users can also benefit from RMW Zenoh. Having said all of that, what does the road to tier 1 status look like? So what tier 1 means in the ROS ecosystem is basically it's supported as a first-class citizen. It will be run on all our nightly CI jobs. We will be distributing it with the next ROS release. So there's a few things that we want to get done in order to achieve this status. First and foremost, we're looking to get RMW Zenoh up to this status by the next ROS release. So this is Kilted Kaiju, which is expected to come out in May 2025. So less than half a year from now. And one of the most important things we have to do is get all of those system tests to pass. As mentioned previously, we have less than a dozen tests that we need to get to that mark, and it's looking really good. Apart from that, we want to provide a better out-of-the-box experience with starting the router. So that's something that users have to be mindful of right now. We're still figuring out what's the best way to have this router or process kind of start up, being able to detect whether it's running or not in the system, and also being able to run it in GitHub Actions and other CI jobs. So that's going to be on our list. And last but certainly not the least, we want to support full security here in RMW Zenoh. This would be achieved by means of access control, encryption, and authentication. We currently have SROS2, which helps generate some security enclaves with DDS. So we need to think about how can we either have SROS2 do the same for Zenoh, or maybe come up with our own mechanisms to generate these configs. In the meanwhile, we're testing extensively and exhaustively, not just with CI tests, but also in real-world applications, mainly to address all of the problems we've had with DDS in the past. So we're specifically targeting those use cases that we found problematic, such as sending large payloads over Wi-Fi. For example, dense point clouds, or running SLAM or vSLAM on a Raspberry Pi and having all of these topics visualized on your laptop. Being able to kind of connect to nodes or ROS nodes across the world, and then obviously run really intense applications like OpenRMF and move it to, and again, dense warehouses and complex environments. We can't do this by ourselves. We need everyone's help here to continue testing RMW Zenoh, uncover all the rough edges so that we can get it to tier 1 status, and also have everyone's applications work really well out of the box. That's really important to us. So please give it a shot and open a ticket if you come across anything. That's all I had for today. So thank you very much. Over to you, Angelo.
Thank you very much, Yadu. As always, great presentation. And I don't know if, I think you made a very good point. I'm not sure everyone in the community appreciate the positive impact that there is on the entire Zenoh stack just because of the level of testing that we're getting from the RMW, right? There are hundreds and hundreds and hundreds of tests, right? The RMW, the RCL, the NAV2, and so on and so forth. So that's incredible.
Exactly. So we're testing low-level packages, but we're also using frameworks like NAV2, and we're trying to run their CI to emulate an actual application.
Which is like system testing, which is
exactly
great. And I mean, up to what was it? A couple of days ago, I mean, in the community, people are trying, but please keep trying. Try even more. You know, we are always any bug we discover, we're always happy, right? So anything we can improve, that would be great. So there was a question. So Yadu, yeah, you still hear me? So there was a question. I think Julian, you're answering, right?
Yes.
In real time. But in short, right, there were some people asking, do you want to come by? Yeah. So there were some people asking if they have to change any configuration when using the ROS2 bridge, right?
Yes.
So in order to do cloud-based communication.
Yes.
The answer is
no. You just need to change the configuration of the bridge to connect to the IP address and port number of your Zenoh router in the cloud.
Yeah.
So for this, you edit the bridge configuration in the connect endpoint setting. You add TCP/IP of your router colon 7447. And that's it.
Yeah, and I think maybe as we are talking about this, so stay. Maybe you can sit. It's also important to understand that with the RMW, with the Zenoh RMW, now we have full support for the ROS graph, things that, for instance, we don't have on the bridge, right?
Yeah.
So people should really migrate to the RMW because that's what will give you the full ROS experience, right?
The full ROS graph, yes, across several hosts and across several routers, right? While in the bridge, you can still locally see the ROS graph, but you don't have a full view of a complete ROS graph across bridges.
And again, the advantage is that you still have an intermediate as we finalize that, but it's getting, as Yadu mentioned, stronger and stronger every day. Okay, so Yadu, let me bring up the next speaker. So let me welcome Pete Levasseur.
Hey there.
From Woven Planet. And so Yadu, thanks again. Thank you very much. See you soon somewhere, right, around the globe. And thanks again for a great presentation. So